Welcome, this is your teacher David Garcia, and today we will be working with parabola properties. Now, before we begin, we have to remember that parabolas can have different orientations. They can be vertical or they can be horizontal. The next thing we have to know is that we will be working with what is known as the vertex form of the equation. That looks like this. This is for vertical parabolas, and this is for horizontal parabolas. Now from here, we jump onto the properties parabola. We have the vertex, we have the axis of symmetry, focus, directrix, the direction of the opening, and finally the length of the latus rectum. Now, in order to understand these concepts and these properties, let's take a look at them graphically. So first of all, let's see the parabola. Here it is. This little curve that we have in here is our parabola. Now, the vertex can be understood. All right, first of all, there's the vertex. Okay, is this little point that we have in here. Can be understood as the maximum or the minimum point of a parabola. If you see in this case, the parabola is opening upwards. Therefore, what we have as the vertex is the minimum point. If this parabola would be opening downwards, such as this way, then the vertex would be the maximum point. And then we have the axis of symmetry. The axis of symmetry is this green dashed line. And if you see, it cuts the parabola exactly in half. So it works very much like a mirror on both sides. Then we have the focus. The focus is a point found on the axis of symmetry. Here it is, this little point. And then the directrix. There we go. It's this line here. And we will see how these two properties are important in a second. Now, finally, we have almost finally, we have the direction of the opening. In this case, we just have to see where it's opening, or in this case, it's going downwards. And we said that it can also look in this way, that it's going upwards. And finally, now we have the length of the latus rectum. The latus rectum is a chord. I'll show you, here it is this line. It is parallel, if you see, to the directrix, this blue line down here. It crosses through the focus, and it begins and it ends on the parabola. Now, why is the focus and the directrix so important? Because these two properties are what define what a parabola is. A definition of the parabola states that it is the set of all points on a plane that are equidistant. That means that they are equally distant from a given point, in this case the focus, and a given line, in this case the directrix. That means if I move this point P, which will move along this curve of points, I will see that the distance between this point and the focus, and this point and the directrix, which are in here, calculated in this square and this square, they will always be the same. Doesn't matter where that point is found, those distances will always be the same. And geometrically, this is the definition of a parabola. So let's go back to our board and let's solve a problem. Let's see an example on how this will work. There we go. Let's imagine that we are given this conic, 2x squared minus 20x plus y plus 51 equals 0. I have explained how to move from this conic general form to the vertex form of the equation of a parabola. So I'm going to do it a little bit faster. So I will have y plus 51 equals negative 2x squared plus 20x. Y plus 51 equals, I am going to factor the negative 2 that multiplies x squared minus 10x. I'm going to leave some space in here to complete my trinome. And I'm going to do so by dividing the negative 10 by 2 and then square it, which will be 25. This 25, let's remember, that is being affected by this negative 2. What I do on one side, I do it on the other. That means that I'm going to subtract 50 on the other side. So I end up with y plus 1 equals negative 2 times x squared minus x plus 25. Now I am going to factor this trinome. So I have y plus 1 equals negative 2 times x minus 5 squared. And then finally, I do the last isolation. Have negative 2 times x minus 5 squared minus 1. So what I have done, if you see, is reach the vertex form of the equation. So let's put it over here. There it is. I have written the equation in such a way that I have the value for this number, the value for h, and the value for k. So now that I have these three values, I can easily calculate the rest of the properties. So let's begin. If you see the vertex, it states that it'll be the point at h, k. So my vertex in this case will be 5, negative 1, which I find in here, 5 and negative 1. The axis of symmetry will be the line x equals h. So in this case, it will be x equals 5. Now my focus, in this case, my focus will be h. So no problem in here. I know that h is 5. Then I have to perform an operation. That will be k, that is negative 1. And then plus 1 over 4 times a. A, if you remember, will be negative 2. So let's do that. K will be -1 plus 1 over 4 times -2. In this case, I end up with -1 minus 1. So this will be -9/8. That means that my focus will be found at 5, -9/8. Now I have my directrix. My directrix will be the line where y equals k minus 1 over 4a. So in this case, I will have that y equals k, that is -1, minus 1 over 4 times -2. So I have that y will be -1 plus 1/8. So I solve this and I have that y will be -7/8. I have my directrix ready. Now in this case, the direction of the opening is determined by the value of a. You remember, a equals -2. So if a is less than 0, then I will have a downward parabola. A equals -2. Therefore, my parabola will be pointing downwards. And finally, the length of the latus rectum will be determined by the absolute value of 1 divided by a. So I do my substitution, and I have that the absolute value of -1/2 will be 1/2. Later on, we will be using all this information to graph a parabola. So far, our objective was to move from the general conic equation to the vertex form of the equation to obtain these three values, a, h, and k, and use them to calculate all the properties of the parabola. Thank you very much, and I will see you on our next video.